Okay, so I'm going to be talking about the light waves and how that applies to our little technical document project. Over here on this side of the radiation, the electromagnetic radiation spectrum, you have the shorter waves, which are like the radio waves, and they have like a slower frequency, and it's less frequent, and they're longer they're longer waves, so they have less energy. And through this spectrum right here, it gets all the way up to IR. Goes through the radio stations, gets up to IR, and then we get to the physical. If you get farther past the visible light spectrum, you get into the harmful rays like the X-rays, or the ones that have a lot of energy, which is the gamma rays. These gamma rays have a very high frequency, and because they have a high frequency, of course, they have a lot of energy. So at the visible light spectrum that we have here, there are three main colors: red, green, and blue. Those three colors in equal parts would make white. And the opposite, those opposing colors, which would be cyan, yellow, and magenta, in equal parts would make the color black. And so, like as stated, anything that reflects colors would absorb. White is something that reflects the colors, and black is something that absorbs the colors. Interesting thing about all these colors is that they each have their different wavelength, and so you see them in the spectrum according to their wavelength, and also according to their energy level. Another cool fact about wavelengths is that your eyes are like antennas that pick up electromagnetic radiation. And the reason that at a quarter wavelength, it's optimal for an antenna to receive that radiation is because you get the greatest amplitude at that quarter and at that 3/4 mark.